Millions of chemicals are used in industry, and workers are exposed to these chemicals in their normal working environment. If chemicals are not controlled, they can harm workers in different ways. The chemical is entering our body by inhalation, contact, and sometimes ingestion, eating or drinking. Chemicals are posing two types of hazards to the workers: health hazard and physical hazard. It is highly important to know the potential dangers and risks posed by the chemicals and take appropriate precautions to work safely. Ensure that all the chemicals or substances coming inside the workplace have MSDS. Without MSDS, do not allow to enter the chemicals. Loose or damaged chemicals shall be reported to the safety department, not allowed inside.
Chemicals having different types of hazards, they are posing safety issues, health issues, and physical problems such as fire or explosion. It is important to keep control of chemicals and other hazardous substances that are coming inside the workplace. While checking the chemical substances on the gate, that is packed in safe packing. It has appropriate documentation and information. Check it has labeled properly and clearly. Hazardous classification signs and information. Material safety datasheet is accompanied. Call and confirm with the end users about the delivery. If it is for use of the contractor, confirm from the host department that substance is needed, approved. If no label and information available, consider it as a hazardous substance and decline the entry. The Chemical Material Safety Data Sheet is a document that is mandatory to have with each chemical. This document shows how to work safely with chemicals. What are hazards and what controls can be implemented? SDS has 16 sections. Each section explains a specific item such as the name of chemicals, hazards, fire controls, exposure controls, handling, transportation, first aid measures, ecological information, physical properties, composition, identification, accidental release, stability and reactivity, disposal, regulatory information. Chemicals are divided into 9 classes based on their hazards and then divided into subclasses based on the intensity of the risk they posed. This classification is done by the UNO and this is called UN Dangerous Goods Signs. These signs give a fair indication that what type of hazard it could present to the workers. If you find chemicals without proper documentation, do not use them. If there is a chemical found in an unsafe condition or unsafe packing, call HSE or the department to which it belongs. In 1983, the federal government established the OSHA Hazard Communication Standard. This standard is designed to protect employees who use hazardous materials on the job. The HAZCOM states that companies that produce and use hazardous materials must provide their employees with information and training on the proper handling and use of these materials. You, as an employee, have a right to know about the hazardous materials used in your work area and the potential effects of these materials upon your health and safety. Employees often ask themselves the following questions. How can this material hurt me? What can I do to protect myself? Where can I find the answers to the first two questions? Your most immediate source for information can be found on labels attached to containers that hold various hazardous materials. Your second source of information is safety datasheets, MSDSs. Material safety datasheets will be discussed in the next section. The OSHA Hazard Communication Standard requires that all hazardous materials be labeled. Labels must appear either on the container itself, the batch ticket, placard, or the process sheets. Hazardous chemicals in portable containers which are for the immediate use of the employee who performs the transfer is the exception to this rule. OSHA requires that the following information be included on all labels. The product name, a warning statement, message, or symbol. On commercial labels, manufacturers of hazardous materials must include their name and address. Many manufacturers also include a statement describing safe handling procedures. 1. A warning statement, message, or symbol. 2. The product name. 3. Safe handling procedures. 4. Manufacturer's name and address. Example. Warning, may produce damage to central and peripheral nervous systems by skin contact or by inhaling vapors. Contains N-hexane, Cas 11054-3. Avoid inhaling vapors or skin contact. Use only in a well-ventilated area. When using, do not eat, drink, or smoke. If swallowed, do not induce vomiting. Call physician immediately. Address of the manufacturer. In addition to commercial labels, many organizations use labels such as those shown below, or your organization may use a specially designed label that contains the same information. Contact your supervisor for more information about the labels used by your organization. NFPA presents the 4-diamond where each diamond represents the specific hazard for the chemical. Each diamond is then provided a number from 0-4. The number represents the severity of the risk posed by the hazardous chemical. The blue color is representing the health hazard, and the number is 3, which means the health risk is high. The red color is showing the flammability and the 4 is showing the chemical is extremely flammable. Yellow represents the reactivity of the chemical, 3 means the chemical is highly reactive. White color represents the special hazard, the cross W shows do not mix with water. MAS presents the 4 strips where each strip represents the specific hazard for the chemical. Each strip is then provided a number from 0-4. The number represents the severity of the risk posed by the hazardous chemical. The blue color is representing the health hazard, and the number is 3, which means the health risk is high. The red color is showing the flammability and the 4 is showing the chemical is extremely flammable. Yellow represents the reactivity of the chemical, 3 means the chemical is highly reactive. White color represents the special hazard, the cross W shows do not mix with water. While labels are an effective way to display information about hazardous materials, there will be times when you will want more information than can be included on a label. You can find additional information about the hazardous materials you work with in what is called a Material Safety Data Sheet, or MSDS for short. You should take time to read and understand the MSDSs describing the hazardous materials present in your work area. A safety data sheet, MSDS, provides detailed information about a specific hazardous material. An SDS contains the following main information: identity, name of substance, physical hazards, target organ, health hazards, routes of body entry, permissible exposure limits, PEL, carcinogenic factors, cancer-causing, safe handling procedures, date of SDS preparation, control measures, personal protective equipment, emergency first aid procedures, emergency telephone number, contact information for the preparation of the sheet, special instructions. Material safety data sheets must be available for all the hazardous materials present in your workplace. You should use an SDS whenever you need additional information about a hazardous material that is not included on the product label. For example, you have spilled nitric acid on the floor, and you need to know how to clean it up safely. You need only refer to the Safe Handling Procedures section of the nitric acid MSDS. Some chemicals, such as sodium hydroxide, are very dangerous. If you have an accident, you may not have time to look up the information you need in an SDS. You should read the SDS for the hazardous materials present in your work area before you work with them. Ask your supervisor or manager where SDS is located. Take time to read the SDS which describes the hazardous materials present in your work area. Remember, knowing where SDS is located and how to use them is your responsibility. It is part of your job. Are one of two major classes of hazardous materials covered by the OSHA communication standard. The other major hazard class is health hazards. In this session, we will be looking at various types of physical hazards and what you need to know to use these materials safely. To help you identify materials that are physical hazards, the symbols shown here are often used. There are three classes of materials that use the fire symbol. Flammables can be gases, liquids, or solids. Flammables ignite easily and burn rapidly. Liquid flammables have a flash point under 100 degrees Fahrenheit. Flammable is subdivided into flammable, highly flammable, and extremely flammable. Combustibles are like flammables, but they do not ignite as easily. Liquid combustibles have a flash point above 100 degrees Fahrenheit. Pyrophoric, or spontaneous combustion materials, burst into flames on their own at temperatures below 130 degrees Fahrenheit. Whenever you work with a material that uses the fire symbol, be sure to read the warning label and the MSDS for safe handling procedures. With flammables, combustibles, and pyrophoric, do not expose these materials to sparks, flames, or other heat sources. You must also not smoke or light a match or flame near them. Explosives are materials that release a tremendous amount of energy in the form of heat, light, and expanding pressure within a very short period. Water reactive reacts with water and may explode, or they may release a gas that is flammable. Unstable reactive are chemicals that can react or can become self-reactive when subjected to shock, pressure, or temperature. Whenever you work with a material that uses the explosive symbol, be sure to read the warning label or the MSDS for safe handling procedures. Because materials that use the explosive symbol are often very dangerous to work with, you may need additional training or instructions from your supervisor. Always check with your supervisor before handling or using materials that use the explosive symbol. Oxidizers cause other substances to burn more easily through a chemical reaction or change. Organic peroxides contain oxygen and act as powerful oxidizers. These chemicals are critical and behave differently when reacting with air and moisture. Whenever you work with a material that uses the flaming O symbol, be sure to read the warning label and the MSDS for safe handling procedures. Many gases such as nitrogen, oxygen, and acetylene are used in the manufacturing process. In order to transport, store and use these gases, they are bottled under great pressure in tanks called gas cylinders. Great care should be taken when you handle gas cylinders to ensure that they are not damaged when they are moved or used. In addition, you should read the warning label and the MSDS for safe handling procedures concerning the gas contained in a gas cylinder. Refer to the color coding for the recognition of the correct gas. The OSHA Hazard Communication Standard requires that all hazardous materials be labeled. Labels must appear either on the container itself, the batch ticket, placard, or the process sheets. Hazardous chemicals in portable containers that are for the immediate use of the employee who performs the transfer is the exception to this rule. The term toxicity is used to describe the ability of a substance to cause a harmful effect. Everything is toxic at some dose. Even water. If someone drinks too much water at any one time, it can cause death. There is a balance between toxicity and dose. The dose is the amount of something you are exposed to or encounter. The less the toxicity, the greater the dose you can tolerate without ill effects. The greater the toxicity, the less dose you can tolerate without becoming sick. Hazard potential is the likelihood that a specific chemical or substance, toxic material, will cause an ill effect at a given dose. The following screens will help you to understand the relationship between toxicity, dose, and hazard potential. For example, acetone is a highly toxic chemical. But you could work safely with it if you were outside or in a well-ventilated room where your dose would be very low. As the chart below shows, your hazard potential for working with acetone in a well-ventilated room would be low. Let's take another example. Nitrogen gas has a low toxic rating. It is found in great amounts in the air we breathe. However, if you were in a confined space that had only nitrogen gas in it, a very high dose, you would soon die because of the lack of oxygen. As the chart below indicates, your hazard potential for working in a room filled with nitrogen would be high. Hazard potential is the most accurate way to rate how dangerous a substance is when used under a given set of circumstances. Neither the toxicity nor the dose rating alone provides you with enough information on how to use hazardous material safely. Your real concern must always be with a hazardous material's hazard potential. Much research has been done by government agencies and groups to establish safe exposure limits for the chemicals used in your work area. These limits are based upon a tune-weighted average. TWAs have been established for all the chemicals you work with and limit the average amount of a chemical you can be exposed to over an 8-hour day. Permissible exposure limits, PEL. It is the concentration of any chemical or substance in the atmosphere that is safe to work with. The substances may be gases, vapors, mists, fine airborne dust, liquids, and solids. Safe PEL shall be getting from the SDS of the substances to work with. Airborne chemicals, substances are gases, vapors, mist, fumes, and aerosols. The safe limit of the substance is measured in percentage in the air. PEL is divided into two further classifications based on the time of exposure. That is called VLTEL, is a long-term exposure limit which safe for working 8 hours. STOL short-term exposure limit, STEL, is an allowable average exposure over a short period of time, typically 15 minutes. PEL TWA time-weighted average, TWA, is the average exposure to any hazardous gas in the workplace based on an 8-hour workday or 40-hour workweek. IDLH immediately dangerous to life or health is an exposure to airborne contaminants that is likely to cause death or immediate or delayed permanent adverse health effects or prevent escape from such an environment as defined by OSHA. The substances are having two types of effects on the health and safety of the workers. Acute immediate, in a short time, negative effect on health and safety of the worker as a result of exposure to the chemical exposure, such as contact with the strong acid, exposure to H2S, or ammonia gas. Chronic delayed, after a long time to appear, negative effect on health and safety of the worker as a result of continuous exposure to the chemical exposure, such as inhaling of solvents, gasoline vapors, asbestos. It's important to remember that hazardous materials present a health hazard only when they come into contact with the body. Chemicals can enter the body in 3 ways. 1. Inhalation. 2. Skin absorption. 3. Ingestion. Inhalation is the most common route of exposure for most health hazards. This includes breathing in dust, fumes, oil mist, and vapors from solvents and various gases. Some chemicals are absorbed into the body through skin contact. If a chemical is readily absorbed into the skin, then the notation skin will appear along with the occupational exposure limits on the MSDS. Corrosive chemicals can cause burns and tissue destruction. Extra care must be taken to prevent skin and eye contact with these chemicals. Therefore, wearing aprons, gloves, eye protection, and other protective clothing is important when working with some chemicals. It is possible to accidentally eat chemicals that are health hazards. To ensure that you do not accidentally eat any of the chemicals you work with. Never eat foods in areas where chemicals are used. Never smoke in areas where chemicals are used. Wash your hands and face with soap and water after working with chemicals before you eat, drink, or smoke. Any chemical that may be harmful to your health is called a health hazard. The following is a brief description of the major types of health hazards. Corrosives cause tissue damage and burns on contact with the skin and eyes. Primary irritants cause intense redness or swelling of the skin or eyes on contact, but with no permanent tissue damage. Sensitizers cause allergic skin or lung reaction. Acutely toxic materials cause an adverse effect, even at a very low dose. Carcinogens may cause cancer. Teratogens may cause birth defects. Organ-specific hazards may cause damage to specific organ systems, such as the blood, liver, lungs, or reproductive system. As with materials that are physical hazards, be sure to read all warning labels and the SDS that provides information concerning the health hazards you work with. There are several ways that you can safeguard your health and physical safety when using hazardous materials. These measures include: do not work with chemicals wherever possible. Product substitution from high hazardous to low hazardous. Prevent the workers from contact, engineering control, covering, separation. Safe work practices, training, procedures, communication, information, monitoring, etc. Personal protective equipment. Chemicals and hazardous substances are major causes of health and physical problems in the workplace. Hazard information plays a big role in protecting workers from the chemicals. Chemicals are affecting the workers by inhalation, contact, and ingestions. Most of the hazard information is available from the labels and SDS. Every company must develop a written program for hazardous communication for the workers. It is the right of the workers and the duty of the employer to protect the workers from hazardous substances. Hazard chemicals are providing information by the size. GHS and NFPA are the most used hazardous sign system. When working with hazardous substances, we shall consider the exposure limits. When protecting the workers, we shall consider to use the hierarchy of controls, and finally, use the appropriate PPE.